Okay, so what is df9d? It is this guy here, right? So row, column. Notice this is actually the index. Yes, the index doesn't have to be just integer or number. It can be text. That's the powerful part of pandas data frame. If it's integer, we can use the range to generate integers, and that's very nice and very cool. But then additionally, it can be like that, because it's even cooler that we refer to standard deviation as code, std uncode, right? Rather than 0, 1, 2, so row number 2. So this is very easy for us to access any particular result from this data frame. And just to see our SS9U again, the number of unique values in DF9. Yeah, so we have gone through this before. For column B, there are 7 cells, but number of unique values, 6. What that means is one of the value is repeated, which is 3 here. Yeah. So of course, if the number of cells in column B, that's 7, is equal to the number of unique elements in column B, suppose this returns 7, then we know that all values in B are unique. That is also one important test property that we frequently will encounter. So are all the values in column B unique? That's this n unique will be very useful. Okay. So next up, we were talking about cumulative, right? So here I think the idea is very simple, because even though the math is may tweak our mind a little bit, uh, in terms of accessing the function and using x is equals to 1 and all that stuff is quite straightforward. So why don't we just run it and uh, feel happy for ourselves that it actually works, right? So where is our 9n? Our 9n was actually defined earlier on here. Okay, let's just copy and paste it again here. Okay, so that we are reminded about the content again. So what is our 9n? It's an extraction of B, C, and D for all the rows. Okay, so when we do cumulative sum, cumulatively adding up the rows. This can be useful, especially if you have time series, right? So as time passes, uh, uh, total number of COVID-19 cases, so that will be cumulative sum, and that just is done directly using CumSum, right? So that's very simple. Cumulatively multiplying through not in this form, because integer multiplying integer, it kind of grows. And but if you're talking about for example this compound interest, and you are having bank interest rates, because as time passes bank interest rates are compounded, but the interest rates themselves are varying, right? If you capture the bank's interest rates, then we will be able to use CumProd to calculate the actual compounded interest. Why I emphasize actual is because if you use formula, the usual principal times 1 plus I to the power of n is assuming that the interest rate doesn't change across many, many years. But these days we know the interest rate, while it doesn't fluctuate a lot, thankfully, it does fluctuate up and down a little bit, sometimes by even up to a percentage point. So if you're having a lot of money, borrowed money, or principal is a lot, it can magnify to a lot of differences between assuming interest rate doesn't change versus the actual changes in the year to year, or even month to month, or even day to day changes in the interest rates. So this is a great way to easily compute, first of all, capture the actual interest rates, then perform the compound interest calculations. Just take the last entry we'll do. Cumulative minimum, cumulative maximums can also find their users in terms of uh, various intermediate calculations for cumulative, complex cumulative calculations. So, but of course, if we like to find the minimum maximum for a column, just do min max will do. Next up, we have frequency tables, right? So this is very important. Usually we find the need to calculate the percentage occurrences, right? So that is why we need frequency. Usually we also like to know the histogram programmatically. Now, why do we need to know that? Because histogram, when it's drawn as a picture, is very helpful to human, but not helpful to computer. Yeah, because computer will have to see the picture. It will be much helpful if we can get a table of the actual values, actual counts. And this is exactly what we are achieving, right? Value counts, then sort by the values. This will give us the sort of Pareto chart that we have been talking about, sort by values. Okay, so SV is sort by values. The last one will be the one with the highest frequency. Then FB will be value count, sort by index. That means I would like to sort by index, right? Then just call sort by index. And of course, the frequency need not be sorted in that sense. Okay, good. Let's print a horizontal bar across. And then we move on to our group by. So we'll do a group by here. Now, once you understand how to call it, how to use group by, all right, and its meaning, and we covered that in the classroom discussion in the previous video. Once you understand it, you can always experiment with B and C and D, so it doesn't have to be always A. So here we group by A and then extract out column C and then calculate mean. We can also calculate mean first, then extract out column C. And it's just how you think about driving the data. So SS9CG, where is it? This is group by A, all right, and then extract out column C and calculate the mean grouped by the unique values of A. So when you run group by, always remember there's this underlying invisible notion of unique values of that column, which is A here. So if you didn't understand this part, didn't have this idea of unique values, you'll be very confused with what is this? How do I interpret this? And so on. So next thing that is needed is always the aggregation function. If you don't have that, let's see what happens. Suppose I call group 9 and group by, right? And say A. And that's it. Okay, that's it. What is it going to give me? It's going to give me this half-baked function, almost like a lambda, right? It's going to give me a half-baked function. If I assign it to a variable, it will still be this half-baked function, ready to move, ready half digested, already grouped by the unique values of A, and then frozen there because it doesn't know what else to do. What do you want me to do? What is your aggregation function? Are you finding the min or the max or the average or mean or what? Right. So you need to supplement with an aggregation function, and you cannot continue with this, right? So we can therefore continue this stuff with dot c dot mean, or we can continue with dot c dot sum. Any aggregation function will do. Dot c dot max. Okay, and the nice thing is this VV, this semi-baked grouped by object, has done the heavy lifting of find the unique values of A, group all the groups together. It's ready. I don't know what to do now, right? This half done heavy lifting is frozen there, and it's nice because you may want to use the group by to calculate mean, minimum, and maximum. Then you can say vv.c mean, min, and max, right? So that's nice. Because the heavy lifting part that I mentioned can take very long if your data frame is huge. So this part, once done, can then quickly apply the selected column or none of it, and then apply and supplement it with the intended aggregation function. All right, so just some extra notes for you. Okay, and of course, a related notion is definitely the pivot table. So for that, we can, let me see how to get this out. All right, so here. So we call columns, right? Columns, pivot by A, by the column. So hang up the unique values of A in the columns. That's what it's trying to say. So columns is A means the unique values of A's hang up in the columns. For group by, we don't have a way to do it. You can calculate it first, then transpose it. But oftentimes, since we have very skillful, easy access to columns and index values, it doesn't sort of affect us in any significant way. Here, if by if it's more readable, more meaningful to put columns, unique values in the columns, then do so, right? And then we print out, and we see that yeah, basically it's doing for um our just like our DF9G, right, where we just calculated the average values, right? So if we do a DF9G dot transpose, it will look the same as our DF9 pivot by A. So if you look at these two tables, they are exactly the same. I am basically transposing the result of group by outcome for all columns and sort of match it against pivot table, and they are the same. So whatever, therefore, group by performs, behaves, requires, pivot table will have to do the same. So remember, group by, it's about unique values. It's about aggregation function. So pivot table, same thing. It's about unique values of A. Aha, what's the aggregation function? As we learned in the slides, np.mean is the default. So we can, of course, hang the unique values of A in the index rather than the column, as we saw in the slide. So if we do that, then it will be exactly the same as our DF9G without transposing. Okay, the outcomes are the same. And for pivot table, it is possible to also like group by the semi-done object and then apply multiple times to different aggregation function. Pivot table, you can include multiple aggregation functions, something that is not so easily done or even doable in Excel. So this is just for showing you its possibility. And of course, for the details, syntax, and documentation, definitely read up, check with the pandas documentation. Next advice is if it gets too complicated that you cannot even understand it easily, maybe just split it up into different simpler steps, because you are going to maintain it, read it again, modify it a little bit. So if you find that, wow, I always have to read the documentation to know what it says, then forget it. Right? Just do it separately with different calls to pivot table one at a time. All right. So let's look at this just for curiosity. What does this return us? It's a pivot table, and the unique values of A are hung in the columns correctly, X, Y, Z. But wait, it's repeated across, all right, because we have different aggregation functions. So pivot table performs one calculation. I meant to highlight this A min part, this block here, performs one time, two times, and three times, and it has to therefore repeat the unique values three times, once for each aggregation function. Okay, and yeah, that's the idea. All right, so at this point, I think we are done with our demonstration. So thank you very much for following through, and join me in the next video segments where we'll discuss one very important aspect of Pandas data processing and analytics, and that is permanent storage. Sounds exciting? Okay. All right, so see you in the next video segments.